Problem 8 on our fraction review. We have two problems and it says reduce if possible. One of these will reduce, the other will not. In order to divide out factors, you must have products. The first one, A, 5x over 10, does have products. The numerator is 5 times x. The second one is an addition. It is not a product, so it is not going to be able to have anything to divide out. So for the first problem, we could divide out the common factor of 5, or you can write primes if you want. If we wrote the primes, 5 is already prime, and 10 is 2 times 5. The 5 is your common factor to divide out, and it leaves you x over 2. If you wrote 1 in front of the x, that's okay. For the second one, you're not allowed to take anything off. You can't reduce the 5 and the 10 because of the plus. That entire numerator has to stay together. So this one is already reduced, or already in lowest terms. Problem 9. This is a complex fraction, which means it has a fraction within a fraction. What we're going to do to it is we're going to write it across instead of up and down. So it is a half divided by 3/4, and then we would know what to do with it. It's just a division. So division, remember, you change to multiplication and invert the divisor. So you have a half times, I'm going to flip over our divisor, 4 over 3. And once you have multiplication, you look for common factors on your diagonals. So in this direction, we can divide out the 2. 2 will go into 2 one time, and 2 into 4 will go 2 times. There's nothing on the other diagonal. You don't care about the 1. And so we'll multiply across. 1 times 2 is 2, and 1 times 3 is 3. So 2/3. Problem 10, we're going to write in lowest terms. So this is a reducing problem. This is a very large problem, and it has several variables, so we're going to go to primes. So on the side, I'm just going to break down 60 with a little factor tree. How about 6 times 10? And 6 will give us 2 and 3, and 10 will give us 2 and 5. So I have 2 2s, 1 3, and 1 5. And for my variables, I can just write them out. So x to the 4th means I have 4 x's, 1 y, and 1 z. Now we'll work on the denominator. 36. So 36, we could do 6 times 6, and that will be a 2 and 3 and a 2 and 3. So 2 2s and 2 3s. 3 x's, 3 y's, 2 z's. And then you're going to divide out common factors. So you're just going to match up and divide out. So the 2's are gone. One of the 3's is gone. The other one has to stay. They have to be 1 to 1. And the 5 has to stay. The variables work exactly like the numbers. Just match them up and divide out. So we have 1x left. For the y's, one of those can go off, and 1z can go off. Now we'll put it back together. So on my numerator, I have left a 5, 1x, and that's all. On the denominator, I have a 3 and 2 y's, which would be y squared in exponential form, and I have a z. Problem 11, we're going to simplify, so we're going to go according to what the problem says. It is a division. So we're going to change it to multiplication and invert the divisor. So the first fraction will stay the same. We're changing to multiplication, and we're going to flip the second one over. So just a multiplication of fractions. The numbers are a little bit bigger. We can probably go with some canceling. If it bothers you with the variables, just leave them until the end. So I think we'll go that route. If we try to simplify on this diagonal, 17 and 13, they're both primes. There's nothing you can do. So we'll leave those. On the other diagonal, 24 and 18, if you realize that there is a common factor of 6, so we could divide by 6. 6 into 18 will go 3 times, and 6 into 24 will go 4 times. So let's multiply across, and we're just going to carry our variables over. So I have 17 times 3, which will give me 51. I have a y squared and an x, so I'm going to go to alphabetical order. And my denominator, I have 4 times 13, which will give me 52. I have an x and a y. So, for my variables, the x's are going to cancel. This is 2 y's and this is 1, so one of them will cancel off. So we'll take this off, and that'll leave just 1. Match it up with this one. And we'll just rewrite. So we have 51 y over 52. 51 and 52 are consecutive numbers. They are not going to reduce. So problem 12, we have a multiplication of fractions. This one we notice is all variables. So what I think I would do with this one is I would just break it down and put all of it in the answer. So I'm going to go across. I'm going to keep alphabetical order. So with my numerators, I have an A, I have 3 B's, and I have 1 C. For the denominators, A squared would mean I have 2 A's, and I have 2 C's. And now just divide out. So I can take out an A, and I can take out a C, put it back together. I have 3 B's on the numerator, which would be B to the 3rd. And I have an A and a C on the denominator. I think this is the easiest way to work one that has so many variables. From problem 13, we're going to convert to an improper fraction. So remember, we're going to take the whole number times the denominator, add back the numerator, and put it over the denominator. So I'll write the steps in case you need them later. The whole number times the denominator. We're going to finish that. We're going to add the numerator, and it all goes back over the denominator. So 2 times 5 is 10, 11, 12, 13, and it goes back over the 5. For this problem, we're going to go the other way. We have an improper fraction. We're going to convert it over to a mixed number. You divide denominator into the numerator. So we set up with long division, 3 into 5. And we divide 3 into 5. We'll go 1 time, multiply back. 1 times 3 is 3. Subtract. Your remainder goes back over your divisor as a fraction. So 1 2/3 is the mixed number that's equal to 5/3. In problem 15, we're going to graph 1/4 on a number line. 1/4 is a proper fraction. That means it's less than 1. It is positive, so it's going to be between 0 and 1. So if we mark our number line, we'll say we have 0 here and 1 here. 1/4 is going to be between those. So the denominator tells you how to cut it apart. We need 4 sections in that unit. So I'll just cut it. That makes 2. So I have 1, 2, 3, 4 sections. That is what the denominator needs. And then the numerator is a positive 1. That's your counter. So we will start at 0, and we will move over 1, make our point. So this is 1/4.